Welcome to episode 10 of George's Random Astronomical Object. Every episode, I run a random number generator to select random astronomical coordinates in the sky, and I then search for an astronomical object near those coordinates and talk about what makes that object so scientifically important. So let's run the random number generator. The printout from the generator this week gives the coordinates as 0 hours, 41 minutes, 37.8 seconds right ascension, and -9 degrees, 20 minutes, 33 seconds declination. This printout is rather unusual as the random number generator does not have a printer. But anyway, these coordinates point to a location in the constellation Cetus. If you've listened to my previous episodes, you would have heard me explain that nobody can tell you anything interesting about the constellation Cetus. The specific object that the coordinates point to is the cluster of galaxies known as Abell 85. This was originally identified and catalogued by George Abell using a photographic survey of the sky produced by Palomar Observatory in the 1950s. A lot of clusters of galaxies are now named after Abell, and quite a few of them, including Abell 85, are rather complex and interesting objects. Abell 85 stands out among these clusters because it is very large, containing at least 500 galaxies, and because it is relatively nearby at a distance of about 780 million light-years or 240 megaparsecs. Because of this, a lot of astronomers have spent a lot of time observing this specific cluster. Clusters of galaxies contain not only the galaxies themselves. Relatively thin ionized gas at temperatures of about 10 million degrees Celsius can be found between the galaxies in a typical cluster. The ratio of the mass of the galaxies to the mass of the gas, which is also called the intercluster medium, is about 1:1. This gas is hard to see in visible light, but very easy to see in X-rays. And Abell 85 has some relatively complicated X-ray structures. If this had been a relatively boring cluster where absolutely nothing was happening, then the X-ray images would just show a symmetric sphere of gas that was centered on the center of the cluster. However, smaller blobs of gas have been found to the south and southwest of the cluster, and both of these blobs have been identified as gaseous components of smaller subclusters falling into the main cluster. The southwestern subcluster is actually close enough that the gas in the subcluster is colliding with the gas in the main cluster. Based on these X-ray data, it's clear that Abell 85 is still growing, but the two smaller X-ray sources are not the only subclusters that have been found. An analysis combining the X-ray data with visible light data revealed that Abell 85 recently absorbed two other subclusters, and a third subcluster has recently passed through the core of Abell 85 along our line of sight to the cluster. The chaotic motion of the galaxies through the cluster causes some interesting interactions. Galaxies outside of clusters pass through parts of extragalactic space that are virtually devoid of just about everything, so they will not change that much unless they pass too close to other galaxies. Galaxies inside clusters, however, are effectively passing through giant gas clouds. The stars within the galaxies can pass through the gas with no difficulty whatsoever, but the interstellar gas within the galaxies will collide with the intercluster gas within the clusters. These collisions cause shock waves that initially lead to the interstellar gas clouds collapsing to form new stars, and in fact, galaxies falling into Abell 85 for the first time appear to have enhanced star formation rates. However, the gas in the galaxies will eventually get blown away in a process called ram pressure stripping. One of the most spectacular examples of this phenomena is a galaxy called J0201, which is referred to as a jellyfish galaxy because as it has moved through the cluster, it has left a trail of gas behind it that should make the galaxy look like a jellyfish. Or at least it would look that way if astronomers had bothered to make an image of the gas like they had imaged the gas trails from other jellyfish galaxies. Instead, astronomers inferred the presence of the trail of gas from J0201 based on the stars that formed out of the gas behind the galaxy and did not image the gas itself, so I couldn't find any images that actually made this specific galaxy look like a jellyfish. I'm frankly very disappointed with the whole astronomical community about the lack of cool images of this galaxy. Anyhow, the galaxies in clusters will eventually be stripped of all of their gas and will stop forming stars. And this effect is actually quite visible when looking at galaxies in different regions in Abell 85. Galaxies near the center, where the intercluster gas is densest, look like they contain nothing but old red stars, while galaxies on the outskirts, as well as fresh galaxies falling into Abell 85, are still forming stars. This process of shutting off star formation, or quenching star formation, as astronomers like to call it this because they drink a lot of alcohol when at conferences discussing this type of subject, is very important in the evolution of galaxies in the universe. And Abell 85 is critically important for studying this process in detail. The center of the cluster, like most other large clusters of galaxies, contains a giant elliptical galaxy. The one at the center of Abell 85 is called Holmberg 15A, and it's called this because it was discovered by someone other than Benedict Cumberbatch. Holmberg 15A stands out as unusual because instead of peaking in brightness in the center, it looks like it has the same brightness over a very broad central area with a diameter of approximately 30,000 light-years, or 10 kiloparsecs. It's common in elliptical galaxies to find that the stellar brightness is the same over a relatively small inner region, often called a core, but the core in Holmberg 15A looks really abnormally large. Using a combination of spectroscopic measurements and models, astronomers determined that the galaxy must contain an extremely large supermassive black hole with a mass 40 billion times the mass of the Sun. They hypothesized that the black hole probably ejected many of the stars that had previously been present in the center of the galaxy, which is why the starlight does not peak in brightness in the galaxy's center. Rather strangely, if you do a web search for images of Abell 85, you'll turn up some rather good amateur astronomy images of a supernova remnant that the amateur astronomers will tell you is also called Abell 85. This really confused me for a while until I figured out that they are referring to a different catalog of objects created by George Abell. Apparently, Abell liked staring at as many photos of the sky as possible so that he could create lists of the different types of astronomical objects that he found in those photos. So, Abell created a couple of catalogs of objects that he thought were planetary nebula, and this supernova remnant actually ended up in those lists. Most professional astronomers seem to like to use the name CTB1 for the supernova remnant, but amateur astronomers will sometimes use Abell 85 for it. Keep this in mind if you try looking up images of Abell 85 on the web. The location on the Earth's surface that corresponds to the position of the cluster of galaxies called Abell 85 is an area of grassland between Yankari National Park and Federal Highway F.125 in Nigeria. Yankari National Park actually sounds like a great place to find lots of animals such as lions and elephants and wildebeest. The grassland to the south, however, doesn't sound as exciting. You could say that animals in Nigeria don't like to cluster underneath the same locations where galaxies like to cluster. The website for this podcast is www.randomastronomicalobject.com. You can visit the website to download episodes of the show, read information about the astronomical objects, view images of those objects, and send me feedback. The audio was recorded and edited by George Bendo. The music is Immersion by Sasha Endy at www.sasha-endy.de, which is distributed by filmmusic.io under a CC 4.0 attribution license. The sound effects are from the Freesound project at www.freesound.org. Thanks for listening.